It's sometimes worth spending some time to look left and right. Is it really the use case that matters most, or is it only the tip of the iceberg and the real issues lie below?
Welcome to a brand new episode of our podcast, Human and AI, Mind, Machines, and the Gradient Descent.
Thanks for tuning in, everyone. We are Kees and Uli. We're your moderator for today. And our today's guest of mine is Henning Ochsenfeld. He is the head of data science and machine learning engineering at Siemens Digital Industries. Henning has both hands-on and managing experience in data analytics, and he is running machine learning applications in areas of signal processing, digital energy grids, and discrete industries. So we're really stoked to hear what it actually means of having AI into the project of digital industries. So let's just dive right into it. So Henning, we're really honored to have you with us. And actually, what would be nice thing to start with a short, maybe a couple minutes description of yourself, about who you are, so the audience gets a nice introduction about yourself.
So, as I said, my name is Henning. I'm 35 years old. I'm married, have a son, which is almost 2 years old. I'm living in the hotspot of the Franconian area in Nuremberg city. Maybe I tell you a little bit about my background. I have a background in mathematics, and I studied at Denmark's Technical University. My journey to Siemens was interesting, I think, since during my master's and afterwards at the university, I worked on model predictive control for renewable energy integration and price-responsive energy systems. And there was a first pilot going on these days on the Danish island Bornholm, and Siemens was a consortial partner at that time. And within that project, they directly recruited me. So basically, I only switched sides. And from end of 2011, I worked for the smart grid department in Nuremberg on statistical modeling and model predictive control regimes for renewable energy integration systems with Siemens. Yeah, and since 2014, I'm working for Digital Industries, mainly for the industry service department, and I'm dealing with various data science aspects and machine learning projects throughout various verticals. And I think we'll come to that during our talk.
Yeah, awesome. So that sounds like a geeky Vita, right? Isn't it? Right. Speaking of geeks, we identified that geeks have a high somehow relationship or correlation with great coffee, but not only with coffee, but also with great music, isn't it? And so the question is, are you into music? What would you say? Given the last also maybe challenging time, right? We are currently in here in COVID-19 and so on, right? What's on the hot rotation of Henning? What's the soundtrack like the last couple of weeks?
Indeed, you're right. The correlation to music is 1.0 in that sense. I'm very much into music, so I learned organ and church organ when I was young, and afterwards switched to trumpet. And in regular times, when we're not dealing with Corona crisis, I'm playing in various bands and big band, mainly in jazz bands. And my hot rotation, therefore, these days is a lot of big band play along on YouTube, which is basically replacing my physical bands I used to practice with. Yeah, 99% I would say YouTube play along of jazz and big band music.
What about the next thing about you guys at work? So you guys are, I know from background, is that you're very much using analytics and machine learning for industrial processes. And can you maybe share a couple of use cases around the industrial AI at Siemens that you guys are working on or really excited about?
Excited is the right keyword here. So personally, I love to, let's say with a mathematics or computer science background, it's always interesting to see various industries. And especially here in Digital Industries, we deal with, let's say, food and beverage and electronics and automotive, battery, aerospace. So quite a lot of various stuff. And in our department, we focused mainly on predictive product quality, so to speak. I'll explain that by some examples. In our electronic plants, for example, in Amberg, we manufacture printed circuit boards for the electronics industry. And there we need to test all the boards 100%. And the use case is, for example, to use the predictive power of data and machine learning models to circumvent a lot of hardware testing. So today everything is tested 100%, and with these predictions we can, for example, decrease a little bit the efforts. Or in another vertical like the automotive, it's exactly the other way around. We try to establish models here to predict the quality of welding points. Today, they only test 1 out of 1,000, for example, and by means of predictive models, they want to increase the virtual test coverage up to 100% in order to cover all welding points. Or very interesting cases from, for example, food and beverage. In one use case, we're dealing with a beer quality prediction, where we utilize models to model the relationship between a lot of input parameters towards the target variable, like a beer quality KPI. Very interesting project. And what you see here in all of the domains, we center our work around the models, of course. And this gives us a lot of possibilities in use cases. So be it in the beer case, we can use the model to do some root cause analysis and find out which parameter drive beer quality most or have the greatest impact. Or the other use cases I mentioned, we use the models for predicting. So the machine learning model or the analytical models in general are the basis for our industrial use cases. And it's, as I said, really exciting to deal with this variety of domains.
So if you're by yourself a geek, right? You're working with fantastic people and talent on technology experts. And one aspect, I guess, is always a bit of tricky is when you start engaging, especially in customer engagement. We all are fascinated by the technology, and that's why we are coming with a technology-driven approach to applications, right? And so it's like, hey, we see these capabilities of meta learning or deep nets or generative models or end-to-end reinforcement stuff, right? But when we then go to customers, they say like, I don't care actually about the technology, right? I'm coming from a different spawn, right? Which brought us in the lab to rethink, okay, how do we cope with, let's say, business-centric thinking, first thinking, design thinking. You have also quite a high stack and set an emphasis on what's called the co-creation framework somehow, okay? Can you elaborate how you do it and what's your thought on approaching the customer engagement here?
Yes, maybe a few words to the history. When I started out with all the data science projects, it was exactly like you said. I was fascinated and excited by a lot of technologies and said, okay, let's find customers or let's find projects and brute force massage them into the technology to make a fit happen. But I think the other way around, as you said, is the more sustainable one, to center yourself around the customer and then by certain methodologies extract impactful use cases that really solve a problem and matter most to the customer and also have the potential for a business case. And some years ago, we had the idea to bring together design thinking and data science methods in order to set the fundamentals for our projects right, to really work on use cases that are concretely formulated and really solve a customer issue. And the spectrum of customers is very broad, so ranging from, let's say, very ambitious customers with a digitalization ambition, and they say, let's do something with AI, or I also want to make use of the potential, up to the other range where people really have concrete project proposals and ideas. And to both ends, it's very important to, let's say, narrow the ambitious ones and come to a really concrete project you can work on. And on the already, let's say, concrete formulated project, it's sometimes worth spending some time to look left and right. Is it really the use case that matters most, or is it only the tip of the iceberg and the real issues lie below? And between these spectrum of customer maturity, I would say co-creating methodologies like, for example, design thinking and stuff like that helped a lot to set the basis right for for the subsequent technological work in projects. And it's, by the way, a great way to get a more mutual understanding of a project with a customer and don't have a handover. Here's the data. Here's my use case. Siemens, please work on it. This is more like the co-partnering and the co-creation that also helps in having this mutual understanding.
Oh, great! Because that's a nice way of dealing with the problem of how to do handover and understanding the problem. But there's also some different problems that you have in industry. For me, for example, I'm currently starting my master thesis on the topic of active learning in industrial AI, where I'm trying to deal with the problem of having not enough labels, or at least unclear labels, and having to do things on the edge at the customer, like machine learning models. And there's a lot of things that are not there when you talk about theoretical stuff, but when you go to practice, there's a lot of things you walk into, and like the data quality is one of them. But there's also different things like problems in the technology, the business, all these different things. So could you maybe share some of the challenges you're facing, and maybe also the best practices of how to deal with these?
I would say two dimensions. One is technology, and the other one I would say it's people and culture. Let's start with the first one, technology. I think we could have another talk for a couple of hours to mention all the aspects that come into play when we talk about, say, a solution or service or product development and really implement it in a sustainable manner. I, for example, could recommend the Google paper from Scully et al., where they talk a little bit about in depth about the hidden technical challenges. It's a nice aggregate there. But as you said, also data ownerships and data availability in industrial domains is not as good as, for example, in public domain data. In most of our cases, we haven't had the luck to have tons of data with equally distributed labels and so on. Mostly we are dealing with highly imbalanced data sets. Domain expertise is really rare, which is necessary to label the data accordingly. And also, if you've finished a proof of concept and you could show that there's some potential in data and algorithms that you could solve the problem, it's still a hard thing to realize the savings. So really bring the decisions, the forecasts, whatever you derive to the shop floor, integrate it into industrial automation systems from physical sensors up to the ERP systems. There are a lot of challenges coming along with that. And, when you're talking to customers and you haven't had the chance to execute a POC and you don't know really if it's feasible at all to solve the challenge, or it's also difficult to calculate business cases beforehand, because for lots of the calculations you need a grasp on the model performances, and there you sometimes end up in a chicken egg problem, because customers of course want to know when the return on invest takes place, and models are mainly giving some statistics and sometimes show a lot of variance, and it's difficult to get concrete numbers there, which is also a challenge. On the other hand, I said the second culture and people to get trust in your AI solutions you worked on, to really get the understanding to the shop floor engineers, because there's a totally different language between engineering roles on the shop floor and the academia roles, let's say, of the data scientists and the computer scientists. This language has to be brought together. And you asked about best practices. I experienced, let's say, the best practice is tell the data story. And I mentioned it in the question before. If you can achieve a mutual understanding of your project and the customer is really engaged, and engagement takes place if you really tell by means of his data what you did with it, how you did with it, how you followed the logic, what you did with the model, how models work, and you get a close link there, and you tell it by data visualization as well, then I think there is a good basis for establishing trust and coping a little bit with the people and culture aspects.
Speaking of trust, right? I think from the hype on AI the last years, right? Management, and invests have been pushed towards, let's get the AI journey started. Let's run the first, POCs, and let's bring up a funnel of POCs, and everybody in the corporate inside as well as outside, from our experience, right, has now these enormous sets of POCs running, from the digitalization, more effort like travel reimbursement, OCRs, to really maybe hardcore also industrial machine learning aspects, optimization aspects, right? Though there's still, I feel a bit of a tension, because everybody is like, I'm sick of the POCs. I want to have a scalable business model. I need to jump over and overcome this never-ending proof of concept thing, right? Ain't going productive trap, right? What is that? Why it's so hard, pushing POCs into productive? Can you share some kind of your thoughts on that?
I'm happy that you asked that question, because this is exactly the experience we made. POC is nice to raise the expectations, to show in Jupyter notebooks the potentials, but bring it to production and implementing it, as I said, sustainable. this is a totally different story. And especially in industry, we made the pains, or we experienced the pains of these efforts ourselves in use cases I mentioned before. What does it mean to deal with dynamic and changing IT OT environments? What does it mean to implement in mission critical environments? Because basically sometimes you're replacing hardware with your model predictions. There are lots of efforts in implementing and really getting out of this POC stage. And I would say, because you were talking about traps, I would say you can't overcome the efforts that come along with it, but you can overcome the traps. And here I would mention it's very important to also mix in various other roles. So it's not only the data scientist anymore that follows up on productionizing his models. There's a lot of software development and engineering involved. So this is also what we do in our department, to build up mixed disciplines and get the machine learning engineers, get the software engineers with the data science view or perspective at least, and mix the analytical and the software world together, similar to as you do it on the co-creation part, where you bring business and analytics together and you need to translate. So I think skills and profiles of people and a realistic view on what does it take to implement an industry is very important.
What about this other topic? So the automation of pipelines of machine learning, let's say also machine learning ops, ML ops, is a really big topic in the current times. And I think you can also resonate with the following quote. Like TensorFlow and PyTorch are really nice open source tools, but they're also hard to scale. And what makes specifically ML ops so challenging to organizations?
Scaling is the right keyword, I think. I think if you stick to a one-of-a-kind solution and you build a nice use case, then all these libraries bring what you need. But as you said, if you think about how to scale, I think you should consider again 2 dimensions. One is degree of automation of your whole development and deployment and operation pipeline. And the other one is modularity, because you don't want to engineer from scratch each and every project. So there should be some recyclement, like building blocks you use over and over again. But when you look into the domains from connectivity up to the visualization, you find points where especially the recycling of models, for example, is really hard. So it's sometimes we have to fight against expectations. We think, okay, we did a project and we have a nice machine learning model developed, and now it's not, you can't really replicate it in a fashion copy and paste to other production lines or assets. Here, let's say generalizability and transfer learning and all these points come into play, and it's not an easy game to snip with your fingers and then you have a scalable business out there.
Mm-hmm. But so a bit more specific, what's from your perspective, right, are the key ingredients for a reliable operation of ML in industrial environments? What is needed for having that? Any thoughts?
I would say two main things. One is a high degree of automation throughout all the things you're doing. So from development on over continuous integration and continuous delivery pipelines for high frequency software deployment. So for example, in our use case in our plant in Amberg, we have a recovery time of 15 minutes. So we are basically forced to fix any bug or a new feature within 15 minutes lead time. And here, if you have manual processes involved or people involved in building and packaging and deploying, it will be very slow. So high degree of automation and for high frequency deployment, this is one part. And I think the other one is, since we are in industry and a lot of change and dynamics are going on, I think comprehensive logging and monitoring of your deployed solutions is crucial. And here again, you shouldn't have people watching logging data all day long. Again, a high degree of automation is required in order to detect drifts of data and concepts and so on instantly when things happen, and let's say the reliable output can no longer be guaranteed in that sense.
A different perspective about this automation part is, of course, where the data comes from and how you deal with data. And it's been a trend, I think. I'm not sure how long you've been in the industry, but for me as a student nearly finishing that, a lot of data is now stored in the cloud and a lot of stuff is accessible in the cloud. It's a really big hype and all the courses I've had in cloud computing and so forth. But there's also a little bit of a hype I saw starting about the edge computing and AI on the edge. And I just think that, especially if you go to industrial data and deal with industrial customers, I think with confidential issues, you might have way more stuff you have to do on the edge. So what are the developments you see there and maybe challenges you're already facing when it comes to AI on the edge?
In general, I think I would agree that there will be a shift in the future towards more AI on edge. And we see it in our project, data privacy concerns or even bandwidth for various data streams does not really allow to put everything into cloud. And I think within Siemens, we have excellent preconditions here. So on the one hand, we have all the great hardware portfolio for various edge devices and edge families. And on the other end, we have great expertise in AI in various departments, ranging from corporate technology until the BUs in various disciplines. And I think bring that together, let's say, more efficiently and really think end to end, because this is my perception right now that customers in the market require this end-to-end consideration of AI projects. This could really make us a big player in here because the preconditions are there. And if you look to our big competitors like AWS and Google and so on, they also start to establish this edge portfolio. And we see that they're heavily pushing in branches where we are currently working in. So, and I think what I said before, have a realistic view on how challenging AI in industry could sometimes be. And then maybe think a little bit about if AI sells today in a, let's say, in a scalable manner like our IPCs sell.
And okay, let me think of one more thing that you might be dealing with, because I think that's the most interesting about your field is, so you're very advanced when it comes to AI on the for industry. But one thing you might also be dealing with is the phase of like the last few years of AI. A lot of neural networks and stuff really makes it tough to really understand what's going on there. I think the more classical approaches are way more understandable. How are you dealing with this with customers, for instance, with the explainability of AI? What are the things they request from you? Is this really an issue or not really? How do you see this?
Yeah, on the one hand, you mentioned it in our projects, if you can't really explain the decisions that were made by, for example, deep neural nets and you're outweighing, for example, experienced experts with that decisions, there's always let's say a barrier towards trust. And if, for example, methods of explainable AI could help to also educate other people how these models and algorithms came to the decision they made, I think this would be a great lever to establish more trust in AI systems in general. And maybe I think this explainable AI will play a crucial role, and I would personally love to see more beyond, let's say, industrial domains. For example, when it comes to our daily life, because as you know, we are all affected and surrounded by algorithms making decisions and forecasts and recommendations on a secondly basis in our smartphones and tablets and so on. And I think we are still having a gap of education, especially younger generations. I think it would be very beneficial to make them aware how does our daily life, how does the social media, how does it work? How does YouTube come up with the next recommendation? And maybe explainable AI can help in educating society there, because if we can't avoid AI, it will be circumventing us or surrounding us in the next decades. But I think we can work on education here, and explainable AI will surely be a lever.
This is something you also see at home, like if your son you mentioned.
Yeah, I mean, he's almost 2 years old, and actually I try to hide the smartphone and tablet of him, but I think as soon as he will start to consume the stuff, I will put great effort into to educate and then make him aware what he's going or what the internet presents to him, be it on YouTube, be it on Instagram, on Facebook, wherever he will be or what will be existing at that time. I think this is a very, very mandatory thing that people know that AI is surrounding us and how does it function.
Yeah. Speaking of, being up to date or training, right? Getting hands on, getting into the field, right? If you consider now the last years, right, which have been dominated by, open source movement, young generation, right, keen on having an impact, keen on getting into, deep learning and machine learning methodologies, and the open source and also the publication aspect, right? The space between pure research and on conferencing, let's say, targeting and showcasing its application is being really reduced, right? And it's with the speed of this field is progressing in machine learning methodologies, it's really hard to catch up, right? Because it's really hard to catch up with the latest algorithms, the latest research contributions implemented already in some kind of software development kit. How do you, in our side, right, we try to, we have established since, I don't know, 3 years, I guess, now, an AI journal club, like a weekly reading club for, preparing papers and discussing why is that relevant for industry, why we should have a closer look, right? But it's really hard to catch up, right, with the latest advances. And I assume, right, for you, having this responsibilities and being daily operation and all this stuff, that seems to be really challenging. What's your ingredients? Any recommendations how to keep up with the technology stack?
Yeah, this is indeed a good one. Keeps me up at night sometimes because there's always a fear of losing connection to the market or the technology that's currently being developed, or that could, for example, replace our own developments. Two things. I keep myself updated to an extent possible in blogs and articles on various channels, be it towards data science or on Medium, what latest developers post, or where people play around with stuff. Or my YouTube recommendation system works quite well in that sense. It also recommends a lot of stuff to me. So reading and informing in the net is one thing, and really also with regards to the corporate technology we have, this is of course a contact point where we have regular exchange to see what are latest advances on, for example, trustworthy and AI, what are latest advances on or current technologies we could utilize in industry on future learning, stuff like that. And secondly, I have to admit I'm in a lucky situation that I have a team and the guys are really young and passionate about all the fancy technology, and during weekends or in their spare time, they do the same stuff like me, I think. And it's coming from discussions with the team, and we discuss what's currently going on. Can we adopt to something and so on? So I think it's a mixture of various components here.
Yeah, continuous learning, I guess, is the tagging, right? Which all faces us as technology geeks, right? Exploring, making failures, but learning out of that and keeping the ball. If you look in, in a bit of the bigger field of, what has been contributed in the broad field of machine learning, right? Are there some aspects or certain, events or contributions that we say, like, hey, that's pretty dope, that's pretty awesome?
Yeah, personally, I'm a big fan of reinforcement learning, and especially the latest advances. I mean, latest means, let's say, last 5 years on deep reinforcement learning. I got fascinated by the stuff from DeepMind and how they solved all the Atari games, and the bridge to industry. I saw I had this moment when I saw the breakout game, which was quickly learned in, I don't know, about 300 games. I thought, nice, can be solved with 100% accuracy, so to speak. And then they let it run for a couple of more games, and it came up with an optimized strategy of solving the game. And I thought, wow, this is cool, and all the other games that were solved. But let's see how this bridges to industry. And then I realized there's a huge potential in production optimization and flow control and everything that can be leveraged by these learning agents. And especially when I look in-house and I see our huge simulation portfolio and our expertise in reinforcement learning, I think bringing that together could be a real value, since, talking for automotive, who of the automotive will let you fiddle around with a reinforcement learning agent on a press, for example? It will explode the costs, but with a digital twin or with a simulation model, you could pre-train all these agents, or at least really fine-tune them towards the real applications later on in physics, and this could really be an asset for us.
If you look, then we're playing in somehow ecosystem is one of the main also buzzes around that. We see a strong move in digitalization. We see a strong move on collaborating, what it means collaborating, right? We see a strong move that it's now a partner of networks. We're building these partner of networks. Sometimes they're referred as ecosystems, right? And we see that these networks exist in US centric or Asian centric, but also in Europe. What do you think, what is the chances that and what you maybe find pretty awesome of the European-centric AI ecosystem? Any thought on that?
Personally, I'm looking forward how this big community can be established with all the ideas of the platform and the sharing within the community. What I'm mainly, let's say, excited about are the ideas on guidelines they want to establish around and ethics and responsible usage and trustworthiness of AI. This is what I mentioned before. I think is today maybe a missing puzzle compared to the importance that AI already plays in other markets than not only industry. And in that sense, I think combining all the countries and also following up on that stream, this is something I'm really excited about. Yeah.
With that said, do you have an idea do you already have some internal guidelines you use? Maybe where you are, where you say, well, these things, they're not officially like set in stone yet, but these are things you would recommend as like the first starting point. Like this is really important as a guideline, for instance.
I mean, we don't have official guidelines, but I came along a couple of years ago, a use case where we found out that there were dependencies on shift workers and efficiency KPIs differed between really individual workers on the shop floor. And here we discussed long how to communicate that, or should we hide it because it really affects people and you. It's like the efficiency log of every individual, and sometimes you can read that out of the data, even if personal data is removed, but other variables indicate that or relate to that. So there we had that discussion, but here in that sense, I hope also for a more holistic regulatory framework or guidelines.
All right, thanks. Yeah. So we're almost at the end, but we always want to also a bit of sharing with the audience. Can you maybe share some kind of recommendations, books, courses, right? People for geeks that want to go in the area of industrial-driven machine learning. Any recommendations?
Yeah, I mean, there's lots of stuff around. Personally, I'm twofold in a way that I think the math fundamentals should be somehow present. So any book like, I don't know, a machine learning book from Christopher Bishop or the Elements of Statistical Learning by Hastier, this is maybe they are thick books, but the basics in their introduction chapters could help a lot to get the basics. And then I would say hands-on experience and you really get your hands on in real industry projects that gives the best experience. So deal with imbalanced data, deal with, crappy and shitty data and really unclean data, not the MNIST data set. Yeah, follow up as I said, maybe the Medium articles where people did something during night and set up new workflows and follow that code. That I think could help a lot or could be a good start.
Thanks. So that's for the folks out there. You can now start somewhere. Let's end this session with something a little bit more fun. So I've got 5 phrases here, at least the first part of the phrases. And I'm going to say the first phrase. It's a little game we're going to play. I'm going to say the first part of the phrase, and you continue the phrase as is for you personally, like you would think makes the best. Okay. Innovation is
taking place in real cool projects with a team that's passionate and dedicated, and there you can't really avoid innovation.
And now maybe a very more personal one. My purpose is
exactly what I'm doing right now.
Beautiful. My favorite quote is?
Actually, I have 2. One is from Pedros Domingos. It's no data, nothing to learn. Lots of data, lots to learn. And the other one is, in God we trust, all others must bring data.
Okay, and then last one. My very own superpower is?
Chocolate.
Beautiful ending. I think I'm going to start a craving now. Thank you so much for being with us today. Also, Uli, thank you for co-moderating. I really appreciated your insights and your time, of course, that you invested in us. And with that, I think we would like to conclude this podcast for today. So folks out there, stay tuned. And there are so much more podcast episodes to come. So just stay bold, committed, and open-minded. And, stick around for more. Thanks for being here.
Thanks for having me.
Bye-bye.